Welcome to the Thought Decoders channel. I'm Sean Mixon, the Thought Decoder. Here I teach logic and I help believers to state and to defend their faith articulately and clearly and with reason. If you think about it, I think you can agree that passions are great followers, but they're not great leaders. There are many mistakes, many errors that if you lead with passion, if passions are what lead you, that you can make. Plato realized this. His whole premise of the Republic was to talk about the organization. He compared the metaphor of the body and how the reason was what was supposed to lead, and if the passions led, then the Republic would look different ways depending on what was in the leading role. I've made so many mistakes from letting my passions lead me, but I've been able to avoid many mistakes from letting my reason lead me. And today we're going to jump into this logic. It's such a benefit to think critically, to be able to discern truth, to be able to evaluate rhetoric and arguments that are given to you. I mean, we read so much in the news and debates. We just had a presidential debate, and you can get sidetracked by zingers. You can get sidetracked by emotions, and there are so many assumptions in the world that we make when people speak. They make so many assumptions, and that if you don't know what assumptions they're making, you can be misled even when they're assuming something that you know is false. But since you don't know what is implied or what their ideas or premises are based on, then you just can find yourself accepting things that aren't necessarily true, right? Based on bad arguments. So last we studied William Lane Craig's Learning Logic. This is the kids' book by William Lane Craig. It's funny because it's not a children's book, but he says it's directed for children. Maybe because he has pictures. I mean, but it's really abstract. I guess children can study it and read it, but this is not like, I teach my kids this, but I mean, analyzing arguments and et cetera, et cetera. Maybe his kids were just, I read it, and I have a graduate degree in logic, and it's still very rigorous, and I guess he means it for it to be kid friendly, because it's almost unless the term kid is just not clear, like what age range he means for this to be a book for. Let me see if he has it on the book. Nope, it's not on the front at least. So we are going to look at chapters 4, chapters 5, and chapter 6 today. The third rule, when we left off, we had looked at modus ponens. We looked at modus tollens. And today we're going to look at the third rule of logic. I have rule 3 here on my book, in my book. So this is not really a rule, but it's necessary in sufficient conditions. This is how you understand it's necessary in sufficient conditions. Okay. That's what we want to take a look at today. Necessary and sufficient conditions. just realized I'm looking at the screen. I need to make this a little bigger. Okay. So what does Dr. Craig say about necessary and sufficient conditions? I'm so glad you asked. That's exactly what I was going to tell you. What he says about necessary and sufficient conditions in this book. So, what are necessary and sufficient conditions? So, what are they? Okay, he says modus ponens and modus tollens help to bring out important features of if-then sentences. The if clause states a sufficient condition of the then clause. The then clause states a necessary condition of the if clause. Okay, so let's go back to our examples. If you look in your notes or at the screen, number 1 above says, if God doesn't exist, then objective moral values and duties do not exist. Okay? And remember, I don't know if you remember it. You can go back and watch the video if you forgot. And a conditional statement, number 1 is a conditional statement. It has an antecedent and a consequence. The blue is the antecedent. The yellow is the consequent. Now, what this statement says is that the blue, we're going to symbolize it because in logic we symbolize, so we can take the phrase God doesn't exist and we can say that equals P, right? So when you see God doesn't exist, I want you to think P. This is one of the things we can do in logic. We use variables. Okay? And when you see in the antecedent, objective moral values and duties do not exist, we're going to call that Q. This is just like a convention of logic textbooks. They deal with certain variables. You see them all the time. You see P and Q when you're dealing with arguments. I have no clue. Maybe it's a historical reason for this, but so the P was at the front here. P, we call that the antecedent. What is sedent? What goes at the front of the conditional is an antecedent. What goes at the end of the conditional is called a consequent. Okay? So P is the antecedent. Q is the consequent. You got me? We can continue. One can be symbolic logic, this is the way you identify arguments, the form of argument. You change it into variables, and it allows you to clearly see the form of the argument. So the form is, and I'm just going to use strictly symbols now. P stands for the antecedent. Then you usually have an arrow which indicates the then. Okay, then I can put Q. If P, then Q. This means if P is true, then Q is true. Right? This is the logic of the argument. It says that two statements, the truth of one statement implies the truth of another statement. In other words, the truth of Q cannot be true unless P is also true. So P implies Q. Okay? Let's see if I said that correctly. So the if clause states a sufficient condition of the then clause. The then clause states a necessary condition of the if clause. Okay? So what does that mean? That means that P in this argument form is a sufficient condition. Okay? Now, what are we saying? We're saying that the truth of P is sufficient for the truth of Q. So that if all I know is that God doesn't exist, that's sufficient for me to know that objective moral values and duties do not exist as well. Right? That's sufficient for the truth of the latter statement. Right? So at least that's the claim here. You may disagree, but that's the claim of the argument. Okay? So P is a sufficient condition and Q is a necessary condition. Now, what does it mean to say necessary? That it means it's necessary that Q must be true, right, for P to be true. P cannot be true without the truth of Q. So that means that Q is necessary. Right? Now, P may be false. And Q may be true. But at least you know that Q is a necessary condition for P. Now, what are we talking about? Such sentences as what we see, if God doesn't exist, then objective moral values don't exist. They tell us that if P is true, then Q is also true. In other words, the truth of P is sufficient for the truth of Q. And then we just said that. At the same time, they tell us that P is never true without Q. So that's what it means to say Q is necessary to P. Because P is never true unless Q is true. Okay, so in any sentence of the form P then Q, like you see on the one with the arrow, P is a sufficient condition of Q, and Q is a necessary condition of P. Okay? Let's think about this. If something is blue, then it is colored. So here's the example. A, if something is blue, then it is colored. So what does that mean? That means that being blue is sufficient for a thing being colored. But it does not mean that all colored things are blue. It's sufficient. That's what it means to be sufficient. So you cannot infer that if something is not blue, then it is not colored, right? That's a fallacy in logic. You may think that, oh, if something is blue, then it is colored. Well, look at this chair over here. It's not blue, so it must not be colored. Well, you don't understand the logic, right? Because a sufficient condition doesn't say that Q is not true. It doesn't say that a necessary condition isn't true. It's just saying that whenever you have this first thing, that first thing is if that's true, then that second thing has to be true, right? And it's to say it's necessary, that is to say that whenever you have something blue, it's necessary that it is colored, because blue is a color, right? So blue falls into this category of things that are colored, right? Of colors. So it's a sufficient, being blue is a sufficient condition, but it is not necessary, because everything that has a color is not blue. You can also say if something is red, then it is colored. Right? If something is red, then it is colored. Okay? So you can't say this ball or this pen is not red, therefore it is not colored, right? So it doesn't allow you to infer what is not Q. You can't go from a sufficient condition to infer what something that is not a necessary condition, right? You can't go from blue, something is blue, to something is not colored, right? Or something is not blue, because you know that if it's blue, then it's colored. But you can't infer that since something is not blue, that it is not colored. There may be other things that are sufficient to fulfill the truth of the consequent. I'm going to keep explaining this until I feel like I've explained it well. You know, I'm not in class. I'm a school teacher, but I'm not in class right now, so I don't have to just keep explaining, stop and move on because of time. It's my channel, so obviously I'm just going to keep going because I want you to get this. So sufficient condition. What do we mean by a sufficient condition? Okay? Think about it this way. If here's another example. It's sufficient to eat a hot dog in order for it to be true that you ate food, right? But it is not necessary, because there are other foods that I can eat. There are other sufficient conditions that can be met in order for it to be true that I ate food. So I cannot infer that since I did not eat a hot dog, then I ate some food, because there are other sufficient conditions for eating food. This is the difference between something being sufficient and necessary. Now, I cannot eat a hot dog without it being true that I ate food, because hot dog is food, right? Hot dog falls into that category. So it's Q, the consequent in C. I ate some food is necessary for the truth of the antecedent. I ate a hot dog. I think that's pretty clear, right? Let's demonstrate it some more. And I'm actually showing you a fallacy. When you try to infer that I ate some food or that I did not eat some food from the fact, from a sufficient condition, you cannot, let me put it like this, you cannot infer the falsehood of a necessary condition from the falsehood of a sufficient condition. You cannot infer not Q from not P. You cannot infer that a consequent is false from the fact that a antecedent is false. I've said that 3 different ways. You cannot infer from the fact that you ate a hot dog that you did not eat a hot dog, rather, that you did not eat some food. That's 4 different ways. Okay? I think that that's clear. I'm really talking until I get I mean, I know what it is, but it's been a long time since I discussed it, so this is helping. So the idea of sufficient conditions means that there are certain conditions that could account for the truth of some statement. Like, this tag is colored. This tag is colored. This tag is colored. What condition accounts for it? Well, it's red. Being red is sufficient for it to be true that it is colored. If it was blue, being blue would be sufficient for it to be for the truth of the statement that it is colored. But I cannot infer that, look, it's not blue, therefore it's not colored, right? Obviously, it can have a different color, right? So the idea of a sufficient condition means, often implies that there are other sufficient conditions to make the consequent true. Therefore, you cannot assume that since you know that that particular sufficient condition, like that something is, I know this is red, right? But I know it's not blue, right? So since I know it's not blue, can I infer that it's not colored? No, because there are other conditions that could make it colored. There are other conditions that, if true, makes this tag colored. So those are sufficient conditions. Now, there are different ways people express this. Okay, so how are they stated? Well, we just went over one. They're stated as if-then sentences. If something is blue, then it is colored. They are stated that way. Sometimes only if expresses, especially in philosophy, they use only if a lot to express necessary conditions. Necessary conditions are very powerful, right? Philosophers look for often look for necessary conditions because it helps you to get at the definition of a thing, the essence of a thing, the concept of a thing, right? Its nature. What does it mean to be a human? What is that thing that it has to have in order to be it, right? One thing is, here's a necessary condition. You can have multiple necessary conditions. It must be living, right? That's false. I don't know why I was thinking that. That's not true, but to be a human, like, what do you need? Well, you need to be a descendant of a certain person. Maybe you need to have, you can talk about it on the DNA level. You need to have a certain body plan, body type, right? A certain brain size, capacity. So these questions are extremely difficult. What it means to be a human. I don't know why I thought I was going to solve that, and just off the top of the head, right? But I would say it means to be a human is to be the type of creature that was made in the image of God. So that my interpretation, my definition of being a human is a theological one definition. Now, that entails that this thing that was made in the image of God was also created from the earth, like as it says in Genesis, so that there would be a certain observable analysis that could be done on the components, the constituents, the composition of a human being. You should be able to identify elements that are in the earth because we were made from the ground. So it says about we were formed from the ground, and then there was our structure, but God took that structure and He breathed life into that structure. So that life is something that comes from God, and the structure comes from the earth. Because just as difficult as it is to define what it means to be a human, it's difficult to define death, and it's also difficult to define life. So the most sure things in life are some of the most difficult to define. We can't really peg it down. I can't define death because I really don't know what life is, right? We don't know, and so on and so on. So we know that only if expresses typically, we say a necessary condition, which are more powerful than sufficient conditions, because necessary conditions means that this thing must be true for something else to be true, right? It doesn't need to be true. It's not necessary that something is red for it to be colored. So that may be a sufficient condition, but it is not a necessary. Woo! Ha! I'm so sorry, I just got excited. Excited because I hit it on the head. Okay, so like I say, this is a true study, right? Y'all are studying with me. I'm studying. You guys are studying with me. It's not like I'm like this mastermind YouTube guru. Maybe one day when I've done this for 15 to 20 years, I can be just off the dome and just, I'm a guru in 19 and the 1500s. Abraham Kuyper created the modus ponens template from lambskin. Anyway. So let's continue. I don't know why I rose up all slow. Alrighty, in focus here. That looks a lot better. Yeah, excuse the hair. It's just kind of going everywhere these days. I'm doing like a fro or something. I don't know exactly what I'm doing. I just said I'm just gonna let it grow and cut it when it's about 2 to 3 inches and just keep it like in a fro. And I'm kind of, my mom has curly hair, So I want to see if my hair is curly, and it looks curly, but I don't really know what this is. It looks like hair like wool, but anyway. So what are other ways of stating sufficient? So we say only if. For example, here's an example from the text, Bill Craig's text. Your mom may say, you may go to the movies only if you have done your homework. And he writes, she's saying that doing your homework is a necessary condition of your going to the movies. So necessary condition. Okay, what is this saying? This is saying that there are no other conditions that you can meet to go to the movies besides or other than doing your homework. The only thing you can do to go to the movies is do your homework. You can go to the movies only if you do your homework. So I don't care. There are no other reasons. That's why this is a necessary condition and not a sufficient one. This is interesting. Okay, it's getting good here. All right. So if we let P be, you may go to the movies, and Q, you have done your homework, we should symbolize your mom's sentence as, if you may go to the movies, then you have done your homework. So he's saying that this is the way you would symbolize that. If P, then Q. Or if you may go to the movies, then you've done your work, your homework. Okay. Okay, so if you may go to the movies, then you have done your homework. Interesting. And see how he gets that from you may go to the movies only if you've done your homework. And he separated these into two different statements, which is interesting and demonstrates a logical relationship between the two. That says the mom is saying that this thing can be true. So it's like she's giving permission for him to use his freedom to create a certain reality, right? Because that's what we do with our freedom. We make choices, and choices create reality. We help to create reality. I want to go eat. I feel hungry, and that hunger is I feel that I want a certain state of reality to be true. Right? I want a certain premise or proposition or thought to be true. This thought that I'm not hungry. Now, if that's what I want to be true, then I can choose to act in ways to bring about that effect. Right? So I can choose to go eat a hot dog. I can choose to go eat some chicken. Okay? So my freedom, I can use my freedom in such a way that it brings about the truth of the statement. I don't know how this thing. You better stay where I put you next time. little OCD. This line at the bottom of this video is driving me crazy. Okay, there we go. It's not exactly perfect, but okay, that's fine. Okay, so that's interesting. Those are sufficient and necessary conditions. Okay? So look, what follows the only if is the cue. What goes before the only if is the P. Right? They said, and then he says, this is tricky because when we see the words only if, we might think that we should symbolize the clause that comes after only if as P, but that's not right. Hold on, you may go to the movies and you have done your homework. We should symbolize your mom's sentence as P, then Q. So he's saying that's not right. When you see the words only if, think immediately necessary condition. So this is tricky because when we see the words only if, we might think that what we should symbolize the clause that comes after only if as P. Okay, so yeah, no, he was saying what I was saying. So I misread that. Yeah, so Q. Because I was like, who would think that? That doesn't seem to. Maybe because I know it that I wouldn't think that, but. So only if, what comes after only if is the consequent. What comes before only if is the antecedent, right, of the conditional. So you take that statement and you can break it up into two different statements. So he's saying, the final thing he says is that ignoring the distinction between sufficient and necessary conditions can lead to mistakes. Oh, he gives an example. I was just thinking, like, I wonder what he means, like what he means by that. So, for example, on the basis of what your mom said, you might conclude that if you do your homework, then you may go to the movies. But that's not what she said. She stated a necessary condition of your going to the movies, not a sufficient condition. She said P, if P, then Q. She did not say if Q, then P. Wow. Wow. That is crazy. I don't know if y'all followed that, but this is what he's saying. He's saying that you may think if she said, well, you may go to the movies if you do your homework. You may go to the movies only if you do your homework. He's saying that you may think that that's a statement that they're saying, like, oh, I can go to the movies after I complete my homework. Because that's usually the way people mean it when they say you may do something. But he's saying that she stated the necessary condition. And not a sufficient one. Right? So in other words, she said that doing your homework, that going to the movies, let me just read what he says because this is confusing me. She stated a necessary condition of your going to the movies, not a sufficient condition. She said P implies Q. She did not say Q implies P. So she did not say that doing your homework implies that you're going to the movies. Okay. Right. So you gotta leave the possibility, right, to say that something is a necessary condition is not to say that not to say that it is sufficient for some other condition to make it. So, for example, go back to the hot dog or to the color. She said, you may go to the movies if you do your homework. It's just like saying something may be red only if it is colored, right? It doesn't say that if it is colored, then it's red. Oh, I get it. So the mistake that I was pointing out happens when people confuse or misunderstand necessary and sufficient conditions. Right? And the mistake that I was pointing out is called affirming the consequent. No, denying the antecedent. That's what that's called, denying the antecedent. It's a fallacy, a logical fallacy. So that comes when you confuse the necessary and sufficient conditions, right? Because if something is red, then it has a color. You're not saying that it has to be red to be a color, right? Because we know that that's false. We're not saying that being red is the necessary condition to being a color. We're saying that being red is a sufficient condition for being a color, which indicates that there are other conditions, right? So to say that you may go to the movies only if you do your homework, that's not to say that she may not want it, the mom may not want it, the kid, is it the daughter or whatever, to do other things, right? And we've had that when your parents say, if you want to go anywhere, you got to clean up your room. Then you come back, you clean up your room and say, hey mom, I cleaned up my room, can I go? She said, she may say, did you cut the yard? Did you put up your shoes, and give you all these other conditions, which she was thinking but you may not have interpreted those conditions. So she may make the other conditions more explicit. And if you say no, then she may say, hey, well, go ahead and take care of that. So what does that imply? That implies that just saying that you may go if you do one condition is not saying that necessarily you're going to go just because you did it, right? It's a necessary condition, meaning that if you go at all, this is the thing that you have to complete, right? You have to do this. You may have to do other things, but you must do this. This is a requirement that you do this, right? So that's interesting. There may be other conditions that have to be met as well before you may go to the movies. So if you concluded on the basis of her statement that you could go to the movies after doing your homework, you would be guilty of a logical mistake. So the clause of a sentence that follows a simple if is symbolized P. And the clause which follows only if is symbolized Q. That was pretty good. That was pretty good. Okay, we're going to keep going. Okay, now we are up to logical fallacies. These are errors in logic. Okay, and we are up to the first one. It's like two most common logical errors. This one is called affirming the consequent. We know what the consequent is. If I have this example, if I have P, then Q, what if I didn't change it to like an arrow? Okay, I gotta hit space. If I have P, then Q, P is the antecedent, and Q is the consequent. Okay? I cannot say Q, therefore, and conclude P. All right, so let's go back to our example. Here's an example. If something is red, then it is colored. It is colored, right? That is the cue, and then you go therefore, and conclude it is red. Right? You can't infer from the fact that something is colored that it is red. That's why that's a logical fallacy. Right? And that's a very common one. We take the necessary condition and try to infer a sufficient condition. Right? You say, if I ate a hot dog, then I'm not hungry. Well, you're not hungry, so you must have ate a hot dog. We reason like that all the time, right? In those forms, in those modes, but those are incorrect ways of reasoning. Let's see what example he has. Okay, Dr. Craig has these examples from his book. If Bill and Jan are enjoying soft-boiled eggs, toast, and coffee, then they are having breakfast. Bill and Jan are having breakfast. I should have put the 2 above, but I'm going to put the 3 right here. Therefore, they are enjoying soft-boiled eggs, toast, and coffee. Okay, see how that now one may be true, 2 may be true, but you can't infer 3 from 1 and 2. So that's what makes this a logical fallacy. And I didn't put 1 here, but here's 1. That's premise 1. Here's premise 2. And then you can infer the conclusion from there. Put learning logic. Getting ready for my scholarly career in publishing articles, etc. So I'm trying to master my APA format. Although I don't think they use that citation in philosophy, so. But I'll put WLC 2014. Okay, that's an example of that. See if he has any other examples. He has some really good arguments, really great examples. I'm like, dang, this is, whoa, these are good. great examples. Like he doesn't play around with his examples sometimes. He can be very familiar, mundane, everyday. I wonder if it's a word for that. He can be very, like getting toast. That's a very familiar thing, practical. But then he goes from there to, if God is timeless, then he is unchanging. 2, God is unchanging. And then they try to infer 3, therefore he is timeless. If God is timeless, then he is unchanging. He doesn't change. So I see what he's doing. He argues that God is timeless, sons without the creation of the world. So, in order to think about the way time began, right? Time started. There was you can't say there was a time when there wasn't a time, because you're assuming a time, right? So it's self-contradictory. So you have to say, in the beginning, God created the heavens and earth. See how the Bible says that perfectly, without the vicious, crazy contradiction or loop of talking about time. It just says the beginning, which implies time, but it doesn't imply time before time. So in the beginning, God created the heavens and the earth. Oh, I love me some logic. So he argues that God is timeless without the universe, but once God acts to create, he enters into time, like, because now you have time as a measurement of events, and so once God starts an event, then time simultaneously he enters simultaneously into time, and he talks about simultaneous causation and stuff like that. So God created, like at the Big Bang, when it was like a size of grapefruit, the universe, then it began to expand from a mass of 0, which basically means nothing, right? Because you can't have a mass of 0. But I don't know why they say a mass of 0. There was nothing, then there was something, then it just began to expand, and boom, there was the Big Bang, the pejorative term. So, but they try to argue against him, the B theories of time, the ones that say that temporal beginning is illusion, that time is like slices of time, where like time worms, like who you were in the past is just as real as who you are now and who you will be in the future, that all those times are kind of just the same. That's the idea of the B theory of time. He's an A theory of time, which is like the common sense theory of time, that the past doesn't exist, the future doesn't exist, all that exists is right now in the present. So what happens is God is without the universe. God creates the universe, and his creation is simultaneous with his entering into time. So now he was timeless without the universe, but with the universe, he's not timeless, but he is eternal. He is eternal means he exists throughout all time. So Dr. Craig makes the distinction that God exists through all time, yet he is not timeless. He doesn't change within his nature, but he changes within, not in his essence, but he changes within his features and his properties, right? Because before he created the universe, there was no universe. So God, it wasn't true that God created the universe. But now, once He creates the universe, there is something true about God that wasn't true at a different time. Not a time. Say I just did it again. There was something true about God. There is something true about God without the universe that is true. That is not true with the universe. And that is that the universe exists. Right? Without the universe, then it's not true that He created it. But with the universe, it's true that He created it. Okay? So this has been our lesson for today. I said we were going to go through chapters 4 and 6. 4 through 6. We actually stopped on chapter 5. We looked at necessary and sufficient conditions. And we are looking at now the affirming, the fallacy of affirming the consequent. Remember that sufficient conditions means that there is one thing that can be true that makes another statement true, but it's not necessary because there may be other alternatives that can make that statement, the other statement, true as well. Such as think about something being colored. If a ball is blue, then the ball is colored because being blue is a sufficient condition. But that's not the only way something can be colored, right? You can be yellow and be colored. The ball can be red and be colored. The ball can be pink and all the shades and different varieties in between. And remember, when we are affirming the consequent, we make mistakes because that's a logical fallacy because we want to affirm or try to infer a sufficient condition from a necessary, right? So you can't infer that something is red just because you know it's colored. It can be there's a million colors it can be. So you don't know that it's red just because you know it's colored, right? If I had something behind my back and I say, hey, it's colored, you're like, oh, it's red then, therefore it's red. That's like, no, it's blue, right? So that's not logic. It's not logical for you to do that. That's just a guess. It doesn't follow logically from the statement that something is colored, that thing is red. But it does follow logically that if it is red, then it is colored because red is a color. So necessarily, if it is red, then it is colored. All right. So thank y'all for joining us tonight. This has been the Thought Decoder. We have hit you with Logic Friday. Logic Fridays. And we're looking at this book, Learning Logic. I'm going to make this a thumbnail. Learning Logic with... So if you see the thumbnail and you watch this video, put a comment down in the... Put a comment down in the comments. Put a comment in the comments section. Drop a comment. What do they say on YouTube? Do something like that. Alrighty. Thank you guys. Have a wonderful evening and we will see you tomorrow. I'm trying to make Fridays one of my logic days. I'm going to do logic, skill development, critical thinking development on Fridays. I'm going to try to have a day for philosophy. Maybe that'll be Wednesdays, and but I'm gonna have the normal schedule, but I may just pop on and do random videos too when I'm feeling inspired, because I do that when I'm feeling inspired. So I think it's good for me to have a schedule, and it's good for me to just pop on randomly when I feel inspired, because that just means more content for you guys. All right, thank y'all. Y'all have a great night. Thank you so much. Bye.